Okay, so here we're ready to move on, and as usual, if we're being introduced to a new distribution, we want to get some of the characteristics, some of the statistics of that distribution, and we're going to find the expectation, and we're going to find the variance. Okay, the expectation of the geometric was 1 over p, and the variance of the geometric distribution ended up being q over p squared. Okay, we already discussed how the negative binomial is a generalization of the geometric distribution. Well, let's see how that transfers or translates into the expectation and the variance. The expectation is actually going to be r over p, and the variance is going to be qr over p squared. So both the expectation and the variance were multiplied by r. If you think about it, it does make sense that I was only looking for one success in the geometric, but in the negative binomial, I was looking for multiple successes, r successes. So both of these statements for the expectation and for the variance have been scaled by r. Okay, let's look through an example here. Iona and Juan are playing noughts and crosses. The probability that Iona wins is 0.7. Random variable represents the number of games that they will need to play for Iona to win 7 times. So we've been told to find the expectation. It's r over p. R is the number of successes. P is the probability of success. 7 over 0.7, that gives us 10. The variance, it's q multiplied by r. So if p is 0.7, q must be 0.3. Multiply by r, divide by p squared. And that gives us the variance. Part B of the question, we were told that they change games and start playing chess instead. Now we're going to use the random variable y to represent the number of games that they need to play for Juan to win twice. So that's negative binomial of 2. We don't know the probability of him winning an individual game, so we've just write p. We are told the mean of y, which is the expectation, is 6. So by setting all of this up, we can rearrange and find a value for p, and in this case, p is 2 over 6, or 1/3. We're then asked to use this to find the standard deviation. We'll start with the variance as usual. If p is 1/3, then q is 2/3. Substitute into our expression. And the value that we get for the variance, we're going to square root that to make sure we have the correct standard deviation. Okay, so yeah, once again, the questions are going to challenge you to make good use of these standard results for the expectation and for the variance, and obviously to be a little bit creative in the way you use them in your response to questions and problems that you come across. You've got to be really careful to recognize when it is the negative binomial distribution you're working with rather than the standard binomial or any other distribution. The conditions are we already know the number of successes and we're unsure of the number of trials. So if that's the situation, the random variable is the number of trials needed to get a specific number of successes. We will be working with the negative binomial distribution. All right, so make sure you get enough good practice. Think through each question and whether or not it hits the criteria, rather than just thinking that this unit or this chapter is about negative binomial, so every question will be. I can give you a heads up now that they throw in lots of questions that are not the particular distribution you've just learnt or studied to make sure that you're identifying these distributions correctly. So really think through for each question whether or not it hits the criteria that we're expecting it to.